So welcome back in video based training. In this video I'm going to demonstrate about the subnetting of A class. In my previous videos I have shown you the example of B class as well as C class also. So if that particular is clear to you, so A class subnetting is also not so much difficult. Basic thing, the concept should be clear. Process is same, nothing different. Still, to make you more familiar with the subnetting concept, I'm going to explain you about the A class also. Okay, so let's come. I have given you so many examples in B class and C class. So here I'm going to explain you about the subnetting of A class. Process is, again I'm saying process is same. Suppose I have a class IP of 10 IP series 10.0.0.0 with default subnet mask of 255.0.0.0 and I need to create two subnet in A class. So how we can do that? Let's see the example. Same process. The required subnet is 2 subnet. Same formula, 2 raised to power y. Number of subnet required. What is y? Number of bit to be borrowed from host to network side in a subnet mask. So according to the requirement, we require only 2 subnets. Okay, we require only 2 subnets. So 2 raised to power 1 will be equal to 2. Means in this case we need to borrow 1 bit from host to network side in a subnet mask. So default subnet mask will be this in this case, because this is the default subnet mask of A class. So means by default, if you convert it into the binary, this will be the 1, 2, 3, 4, 5, 6, 7, 8. So 1, 1, 1, 1, 1, and all other are 3 octet belongs to host, and first octet belongs to network. This one. Okay. So according to the requirement, we need to borrow 1 bit from host to network side to fulfill the requirement of 2 subnets. So when we do that, this will be the I borrow 1 bit from host to network side, and when we convert back into the binary number system, decimal number system, the new subnet mask will be 255.128.0.0. Next is the block size. What will be the block size? One thing I want to mention. In this case, which one is interesting octet? As I've told you about the interesting octet many times in my previous videos also. So in this case, the subnet mask will be, interesting octet will be second octet. So we have to take all the variations in second octet only, block size variations. So in this case, block size will be 128, means each subnet or block will have 128 total IP. Always keep it in mind the difference between the total IP and valid IP. So what will be the two different subnets? First, starting from 10.0.0.0, first valid IP will be this, and last valid IP will be this. I want to show you one thing, how I'm doing all these things. I want to show you one side. Why I'm bringing this watch? You can see here, first variation comes into the second, then when this value will reach 59, then variation take place here. When if you compare it with IP address, so consider it as this one as a block, each octet, 1 octet, 2 octet, 3 octet. Okay, so when this value reach, look here, when it becomes 60, then one variation take place at this place. and one point come when this value reach the 59, then one variation take place here and this become 0 and this also become 0. Again the counting start from this octet. Let's keep waiting for some time. 35, 36, 37. I have to wait some. (51), 52, 3, 4, 5, 6. Now observe it. When this value become 59, instantly second octet get changed. His minute get changed. Same thing happen in the IP. So means this value keep changing from 1 to 2, 3, 4, 5, 6, 7, 8. One point comes when this become 255. Then this value become 1. Again the same process start. Then this value become 2. Again the same process. One point come when it become 255. Dot 255. Okay, then this become 1.0.0. So this value keep changing like this. One point come when we reach to the 127.255.254 and 255.255. Means all the octet get saturated. So variation you can take. I have taken the variation in second octet of 128.0 to 127. Only this is the point that you have to consider. Remain all the processes same as we done in the C class, as we done in the B class. Here also 127, block size is 128, so it become 128. 128.0.0.1, and here it will go up to 255, 255, 255 will be the broadcast, and this will be the valid IP range here, and this will be the network IP. Okay, so means block size is 128, so 0.0.0, 10.128.0.0. This will be the two network ID when we want to divide C class into the two subnets. Okay, clear? Take some more example. Second example I am going to take B class. In the C class I have to divide into the 4 subnet. Same IP series 10. So require 4 subnet. Same formula. Requirement 2 raised to power 2 will be 4, means we need to borrow 2 bit. Default subnet mask is this one. When we borrow 2 bit from host to network side, this will be our new subnet mask. When we convert it to the binary 255.192.0.0. So take the block size. 256 minus 192 means 64 will be the block size. Again this variation come into the second octet. So very first network ID will be 0. This will be the valid IP range, and this will be the broadcast. You can see here block size was 64. So I have taken the variation in third octet of 64 bits. So next will be 0.0. You can see here 64. So first network ID will be 0, 10.0.0. Next will be the 64. 64.1, 127.255.254, and that broadcast IP will be 127.255.255. Okay, so very simple concept. Just you should be familiar, you should take extreme care in what block variation comes, which one is the interesting octet here. So 128.0.0.0 will be the difference of 64 here. So first last valid IP and broadcast IP. Here also the difference of 64 between them. And last will be 192. It goes up to First valid IP, network ID, valid IP range. Again you can see the difference of 64 here, and last broadcast will be this one. So this is the A class subnetting. Let's come for one more example of 512 subnet. Here you have to take little more care about the block size and interesting architecture. Same example I have taken for the B class also. So required subnet is 512. That means we need to borrow 9 bit for this particular requirement. So this is the default subnet mask. When we borrow the bit, it becomes something like this. Is 9 bit, 8 bit and 1 bit. Total 9 bit we have borrowed from host to network side. So this will be our new subnet mask. 255.128.0. Sorry, new subnet mask. Then again the block size, we need to consider two block size. One block size for the second octet and one block size for the third octet. So first, naturally, as I have shown you the clock also, first we saturate the third octet. When this octet, you can say, when this area becomes saturated, we give the increment of 1 here. In third octet, variation will be 128, and in second octet, variation will be 1. So first I will consider the third octet variation is the 128, 0 to 127. First valid IP, last valid IP and broadcast IP. In third octet, again you can see I have taken the variation of 128, or you can say block size 128, so variation of 128. Here is little mistake, here it should be first valid IP will be 1, 255.254. Again the variation in the third octet is of 128, and here is the broadcast IP. So keep remaining the same process, continue. When these two octet become saturated, third and fourth octet is saturated, then we give the increment of 1 in the second octet here. You can see here. And naturally fourth octet variation is 128, so 0 to 127, 128 to 255. Now again these two octet become saturated, we give the variation of increment of 1 in second octet here. Again the same thing, second octet 1 variation, here is the 128 variation, 128 variation. So we keep continue like this till we get my very last octet will be this one. Very last block will be 255.0.0, 255.0.1, 255.127.254, and broadcast will be 10.255.127.255, and this will be the end, or you can say last octet. This is the last octet block series. Here first we take the variation of 128, then again we take the variation of 128, and here 255. So this will be our last octet or block of the 10 IP series, classful IP series, when we divide it into the 512 subnet. Okay, so this is all about the subnetting. Now I want to add something more, that is known as the CIDR. CIDR. What does it mean? CIDR. What does it mean? Classless Inter-domain Routing. Inter-domain Routing. What is this CIDR? It's just the representation of subnet mask. Normally we do the subnetting. When we represent the subnet mask, we represent in this way. Okay, na? So when router propagates the routes to its neighbor, it always represent like something. If we go, when we done the routing also, it will represent like this. So what is this 8? What is this 8? So either we can write the subnet mask in this way, 255.255.255.0, or we can also write in like this way, 8. So this is known as the CIDR. What is this 8? This 8 bit. This 8 bit. Means how many bit is on? We can write in this way also. So take some more example, like here, 2 subnet. So in this case, the subnet mask is 255, means 8 bit, and 1 bit we borrow from here. So it can either be written like this, or can be written like 9. Okay. Take another second example. Where we require the 512 subnet. So in this case, the CIDR will be 8 plus 1, 9 plus 8 means 8 bit, 1 bit, 8 plus 8, 16 plus 17. So we can write the CIDR like this also. So CIDR is just alternate way to represent the subnet mask. So if he says for A class, CIDR value can be /8 because the default subnet mask is 255.0.0.0. It can go up to /30. For B class, it can be /16 because default subnet mask is for B class is 255.255.0.0, and it can also go up to 30. And for C class, /24 to /30. This is the CIDR representation of a subnet mask. Okay. So hope now it is clear to you how we can do the subnetting of A class, B class and C class, and also discuss about the CIDR representation. So in my next video I will going to explain you about the variable length subnet mask, because here in case of subnetting we are getting a equal number of IPs in each block. Block size is fixed, so that is also known as the FLSM, fixed length. FLSM stand for fixed length subnet mask. Subnetting is also known as FLSM, fixed length subnet mask. So here we are getting the equal number of IP in each block. In next video I will explain you about the variable length subnet mask. So hope everything is clear to you about the subnetting. If still have any doubt, please write me in the comment. I will try to reply you as soon as possible. Thank you very much. Hope you enjoy this video.